Ever considered a clean approach to waste plastic management? A recent study considered just that. In the research, two promising technologies for transforming waste plastics into valuable fuels, thermo-syngas fermentation and hydrothermal liquefaction, were explored. The key focus in the study was to assess which of these technologies not only helps alleviate the global plastic waste crisis, but also meets the increasing demand for liquid fuels in transportation. To begin with, thermo-syngas fermentation involves breaking down waste plastics into syngas through gasification.
This syngas is then fermented using microorganisms like Clostridium leungdalii to produce ethanol. While the technology demonstrates technical feasibility, the study makes it clear that hydrothermal liquefaction outperforms it economically. Hydrothermal liquefaction operates by subjecting waste plastics to high temperatures and pressures in water, which causes the polymers to break down into hydrocarbons that resemble gasoline. This pathway, according to the study, is not only simpler but also yields higher economic returns. The findings revealed that the hydrothermal liquefaction process was more cost-efficient and scalable. For instance, it was reported that the internal rate of return, or IRR, for hydrothermal liquefaction reaches an impressive 51.3%, in contrast to just 22.2% for thermo-syngas fermentation. This means that investors in hydrothermal liquefaction would see quicker financial returns. Moreover, the cost of processing plastics is significantly lower in hydrothermal liquefaction, with the per kilogram processing cost standing at US 0.38, compared to US 0.42 for the fermentation route. Another critical factor is the payback period. Hydrothermal liquefaction can recoup its initial investment in a shorter time compared to the thermo-syngas fermentation process. One of the major advantages of hydrothermal liquefaction highlighted in the study was its energy efficiency. Since the process is exothermic, meaning it releases heat, there's no need for additional external heating. This drastically cuts down on energy consumption, making hydrothermal liquefaction not only more economical but also more sustainable. The authors also mentioned that the gasoline-like hydrocarbons produced in the hydrothermal liquefaction process are of high quality, largely free of impurities like oxygenates, which makes them suitable for direct use as gasoline blend stocks. Though both technologies aim to address the environmental and economic problems posed by plastic waste, hydrothermal liquefaction stands out as the more practical solution. The study's simulations show that hydrothermal liquefaction could hypothetically convert 1 ton of plastic waste per year into 0.685 kilograms of oil product, containing about 88% hydrocarbons in the gasoline range. This capability makes hydrothermal liquefaction a strong contender for global adoption in regions grappling with plastic pollution and rising fuel demands. It was further suggested that the global application of hydrothermal liquefaction could provide a sustainable way to reduce plastic pollution while also contributing to energy security. The fact that hydrothermal liquefaction does not produce toxic byproducts such as dioxins or furans, which are commonly associated with incineration, adds to its appeal as a cleaner, greener solution for managing plastic waste. The valorization of waste plastics is of particular importance, with the study underscoring the urgency of addressing plastic waste with innovative technologies like hydrothermal liquefaction.
Given its proven economic and environmental advantages, there is a need for further investment and development in hydrothermal liquefaction, positioning it as a leading strategy for both waste management and fuel production. To read more details regarding this work, please feel free to click on the link in the description below.